Hey folks, we'll be starting in just a minute, so please do hold on. Another 30 seconds, and I think we should be good to start. Just let a few more people join in, and then we'll be good.
Hey guys, I'll share the presentation. Is it visible?
Yeah, perfect. It's visible. I hope folks in the audience can also see it. Okay, lovely. So, folks, let's get started already. Firstly, thank you so much for everyone taking the time out to join us. I'm sure everyone had a busy schedule. I know it's a working day. So it means a lot for everyone to take the time out and join us on this session. Um, Quick intro. My name is Sahaj Virk. I'm currently leading the GTM and strategy efforts for all of Sarvam's model APIs. And today we are going to be diving deeper into the speech-to-text API, or more specifically, the Saaras V3 model. As we go along, I'll also introduce some of my team members who will come on speak and talk a little bit more in depth. These are essentially the magicians who have built the model and have put in all the efforts and who have all the knowledge that it takes to really build something from scratch and build it from a customer perspective, right? Working backwards from these use cases. Also, just want to touch upon again that for the folks that stick around towards the end, we do have something exciting. For all the developers that like to tinker, that like to try something new, we do have something that we'd like to share with you. Oh, is my voice not audible? Is it? Oh, one second. Okay. Seems like it is audible for quite a few folks. Okay, perfect. Cool. So yeah, thank you so much for joining. Really appreciate everyone spending the time. And there is something exciting for developers who want to tinker at the end. So yeah, please do stay tuned. Let's move forward. Drew, can you move to the next slide? Folks, the way we'll be structuring the next 60 minutes, we want to give you some insights into how the Saaras V3 model was created, right? What is the sort of philosophy that goes behind it? How we think backwards from use cases for, let's say, particularly designed for India, right? What are the key challenges in all the different use cases that can come up, and how we build backwards from those use cases. And we'll go a little bit deeper into the development aspects, right? Give you some insights into what the modeling process looks like. We'll also talk a little bit about where the Saaras V3 model really does well, stands out, is able to do better and really deliver the kind of experience that we want. Then we'll go a little bit deeper into the API features that you can access today. We'll also give you some sneak peeks into features that will come up very, very soon. And finally, we'll talk about how the Saaras V3 model is being used in production as of today across a bunch of different use cases. So that is broadly how we will structure. I'll just take a short pause. I still see quite a few people saying that it's not audible. Um, just give me 1 second. Let's see. Okay, is it better now for everyone? Okay, perfect. Take care. I'm seeing positive feedback. Cool, lovely. So that is how we'll structure the presentation. Dhruv, let's go to the next slide. So, see, I think one of the key questions, right, for anyone who starts to use a speech to text model, or in fact, the key question for us as we were building Saaras V3 was, ki, hey, where can you fit this model, right? What is the exact problem that it is going to solve? Um, and when thinking about this, there's countless answers, right? There would be, let's say, loan collection agents, there would be language learning apps, astrology apps. The list is endless, right? It goes from anything from related to a voice agent to apps to startups, individual developers. Everybody's building something unique. And then you throw in the mix of Indian languages, right? Different dialects, you throw in different pronunciations for the same language, right? And you throw in background noise. All of these things amount together and become a very complex web. But the way that we broke it down when thinking about it is broadly that there can be three buckets, right? I can essentially put each of the use cases and applications that come up into one of these three buckets, and each bucket has its unique requirements. Let's take, for example, voice agents. That's the first bucket. Here, you're essentially going to get short audio chunks where a user speaks, and you want it to be optimized for latency while probably being able to handle 8 kilohertz telephony audio. The second larger bucket is, let's say, people wanting to get insights out of larger audios, right? Where, let's say, you just have meeting recordings, you have telephonic conversations with customers, or you want to, let's take, understand in, let's say, a medical scenario, what is the conversation happening between a doctor and a patient. Right? So all of those cases where you have longer audios is what we classify as the post-call analytics bucket. And finally, we have the live dictation, right? You think about applications like Siri on your iPhone, right? Where you could just speak and text would keep coming up as you speak. You can see it live with extremely low latency with interim transcripts, which correct themselves as you go on, right? So that gives you a user experience which might be really relevant to anyone building in app, right? So that is broadly how we think about it, right? These three buckets, each of which has its own nuances that have to be solved for. And from these buckets, we sort of built backwards. I think as of today, we have made a lot of progress. I think as we go through the presentation, you will get some more insights into that. But yeah, let's just go deeper. Andrew, we can go to the next slide. Uh, so at this point, I would also like to call upon Abhigyan, who is essentially the lead for the speech recognition team. He is the brains behind the entire ASR model building, and yeah, he'll go and speak more about the different use cases and how we've gone about the deployment. Abhigyan, over to you.
Thanks, Saj. Thanks for the introduction. Yeah, as Saj has outlined, we are catering to multiple use cases, and then we will go technically deep into what powers these use cases. What is the brain behind these our Saaras V3 model? So first is voice agents. As you can see, it's an example where it's showing that we have we have low latency. You can have it synchronous, single request, less than 30-second clip. You just use our REST API endpoint. And one thing you'll notice later in this session, Dhruv will walk us through exact what API specification you should be using for different use cases. Dhruv, next, please. Another use case that we have observed comes in bulk is the post-call analytics one, where we know that people provide long audio chunks up to 1 hour, what we support. People want to do diarization and need not want immediate output. So this is what we call as batch mode, where we allow user to provide audios up to 1 hour. We provide speaker diarized output and in an async fashion. Next one, Dhruv. And the final one is the streaming one. And this is something that we have been building recently. It's in beta right now. Do speak to us if you want to enroll into this. This is a true streaming model. As you speak, the output, the transcription starts coming. And as you can see here, the output gets refreshed at the end. So this is something that we find that it's asked and it's useful in applications like live dictation, captioning, commentary, and all. Yeah. So you will have, in fact, we have already one version which is integrated in LiveKit Pipecast. So if you want, you can start using it. But we have a latest release which we have released in closed beta. But if you want to sign up and see this in action, do reach out to us. Next slide, please. Yeah, so now let's get into the really hardcore engineering stuff, the serious stuff. Uh, and I know I honestly maybe I lose half of you here, which is kind of risk that I'm willing to take. But this is a thing that really powers everything, and you'll get to know the technical know-hows here. So for the geeks out here, I mean, next couple of slides are for you. Next one, please. Yeah. So Saaras V3 blueprint, what was it? We will look into four aspects in particular. One is the data, massive petascale pseudo labeling exercise that we have done. You don't get a model to understand real world Indian speech by hand transcribing. You have to have a very complex, sophisticated pipeline where all the different components, some of them are mentioned here, LID, VAD, segmentation, diarization, timestamping, all of this come together. And then also human QA on top of it to verify the sanctity of the pipeline and deliver the really pristine quality data. Yeah, next one, please. The second aspect is the model. At its core, Saaras V3 is an audio conditioned language model. There is an audio encoder which has been uh, rigorously trained on Indian language data. But the massive differentiator here is our indic aware tokenizer, where we have seen that it is far more efficient. In fact, the number is flashed below 26% token fertility over Gemma 3 tokenizer. Which means efficiency means better, not just accuracy, but also faster and better outputs. We also not just do domain, I mean, we not just focus on the pre-training, but we know that in order to achieve SOTA results, post-training is the key. So we do domain robust post-training. We have extensive RL recipes that we apply on top of it. The third part of it is the streaming, where we want to focus because this is something that we have been building recently. There is a recency bias here. Streaming, we did something novel. We took the same backbone and made it causal. Both encoder and decoder are causal. And we use a mechanism known as chunked attention, which means that we process in 0.5 to 1 second chunk size and preserve the KV cache across these chunks. Because we preserve that state, compute cost is linear and it does not grow with the sequence length. And this is how we get sub 150 millisecond time to first token latency. Next one, please. Finally, the aspect which is serving. The PyTorch checkpoint, as we know, is good for experimentation. But when we actually want to scale up, we need to go lower level. So this is where we take our PyTorch checkpoint, go to intermediate Onyx, and finally into a frozen TensorRT low precision checkpoint. And then apply bunch of optimization techniques on top of it. After that, we have an efficient serving layer where we do things like continuous batching, where the decoder runs one TRT step at a time. And between every step, we drain the inbound queue, admit new request, and evict finished ones. I mean, these are very technical, but I just wanted to push it here. What is the result? You can see in the bottom. We get on a single H100 pod, we get over 90% system memory utilization, serving over 72 concurrent streams. Yeah. Next, please. Yeah. And just briefly, I want to touch upon what we are building next. We have Sarvam audio. We already have it. We showcased in the India AI Summit. This is a true audio language model, which is built by pre-training a text-only LLM first, then teaching it to listen using a very efficient state space model backbone. What it helps with larger context, longer audio, and better context adherence, which is our focus for the next generation. Yeah, next, please. For those interested in the deep technical dive, do check our engineering blogs that are at sarvam.ai /blog/ASR or sarvam.ai /blog/sarvam audio. Do check it out. Yeah. Okay, over the next few minutes, I'm going to we are going to explore where exactly this muscle flexes. I'll walk you through our language coverage, Indic language coverage. So how the model survives real world scenarios, break down our high-speed streaming capabilities, and then give you some context on where are we heading with this contextual ASR. Finally, we will hand it over to Aditya, who is tackling one of the arguably hardest problem in transcription, which is multi-speaker environments. Okay, let's dive in. Yeah, so first step is the coverage. So Saaras V3 natively understands 22 Indian languages plus English. But India doesn't just speak in textbook grammar. We speak in dialects. There are regional accents, and we constantly code switch. Because of all the things that I mentioned before, on a very Indic focused extensive benchmark, which is Indic Voices, we are way ahead of our competitors, 26% in relative WER terms, ahead of our nearest competitor, which is Scribe V2 here. Next slide. But what we care about more, benchmarks is one thing. We care about the real world scenarios. And we have three scenarios here. And maybe Dhruv, you can play the first one, where we are highlighting that when you are speaking brand names or code mix or numbers numeric, it does capture those entities well.
भैया, क्या मेरा सामान मकान नंबर K45 गली नंबर 12 गणेश नगर वाले पते पर पहुंच गया है क्या?
Yeah, so K45, Ganesh number, all these things are something that comes out of our model because it has been so massively trained and pre-trained. Next one, please. This is another example. It's in a different language. You can just play it.
मम जियो मनी वालेट् मध्ये केनरा बेङ्क् अकौण्ट् इत्यस्मात् 9,000 धनं योजयितुं शक्नोषि वा?
Yeah. So you can see that one important, interesting aspect we have shown here, which is the code mix. You will get the English words coming out in English, in Latin, and Hindi or Sanskrit retained in Devanagari. This will, Dhruv will talk more about it when we are doing hands-on API walkthrough. Next one, please. This is the usual scenario that we face a lot of time in our production cases. How do we handle background noise? I can tell you we have done extensive post training to make sure that we handle background noise quite well. Please play it.
अच्छा, मौजूदा सरकार का कामकाज आपको कैसा लगता है?
Okay. Yeah, so any scenarios where there is low SNR, where there is feeble audio, there is crosstalk, we expect that the model will live up to those scenarios. Next slide, please. Yeah, this is where we want to show you our streaming, the latest thing that we have been building up. It's in beta again. Do speak to the team to enroll. Play it here.
Plus 5 seconds.
Liftoff normal.
Here we have a majestic liftoff of LVM-3 M4 rocket carrying India's prestigious Chandrayaan-3 spacecraft.
P2 tracking.
That is one example in how real world scenarios, how our model lives up to that. This is a streaming model, 150 millisecond time to first token. There are three modes, which we'll later talk about it. And we support all the 22 plus English language. Next one. Yeah, this is the interesting aspect. This is what we are calling that next generation. This is just a preview of it, where we are saying that the world is going to be agentic, which means there are a lot of context that feeds into it. So can you go to the first part? I mean, this is a sequence of slide. Can you just, yes, scroll to the first part. So if you play this audio, it's a very short, tiny chunk of audio. Yeah, play.
Yeah, madam.
So it's very convoluted. What it is saying, madam, we can hear it clearly, but it is kya, kyun, ha, na. So it's not very clear without the context. Without the context, if we see the model outputs, can we see it? Yeah, both Gemini 2.5 Flash and the Sarvam audio gets it wrong. Right. Then we provided the context. So this is the previous turn context. We are just showing the previous turn, but essentially, since it can support long context, you can provide all the previous turns. And after you have provided context, this is where we want our model to shine, where you can see that Sarvam audio gets it correctly. Kya, madam? The context, this is the one that makes the most sense. Next slide, please. Yeah, so now we will move on to the, as I told you in the start, the hardest problem of all. We have been seeing just a single speaker transcription, but it's a totally different beast when it comes to two speakers, three speakers, four speakers scenario. To talk about the sheer complexity of diarization and how we are solving the multi-speaker problem, I would like to call Aditya, who has been, amongst many other things, leading efforts to build modules to solve this problem from ground up. Over to you, Aditya.
Thanks. Thanks, Abhigan. I hope I'm audible, folks. Abhigan, Dhruv.
Yes.
All good? Awesome. So yeah, thanks for that lovely introduction, Abhigan. So yeah, we saw Saaras V3 do really good on single speaker. We saw context, but I also saw a few questions. Actually, people were asking, yeah, but I want speaker wise transcripts, and how do I do that? So yeah, so we've also really tried to push the boundaries on multi speaker transcription. And before that, I'll just give you a overview of what it entails to actually enable this in our production environment, right? So yeah, Dhruv, maybe. Okay, so the first issue, right? Like a lot of people also ask me, hey, do you have some numbers? How is your model doing on speaker attribute WER, right? So we have WER, CER, but then when you have speaker uh, kind of speakers in multiple speakers in that audio, you have speaker attributed WER. But that is all fine, but you don't have an indic focus training set. Leave training set, you don't even have a good eval set, right? Out in the public. You know that we have Die Hard, AMI, Call Home, Not So Far. All these are English in this Latin languages. You have French and all the Spanish and Mandarin, right? So that's all that you have out there. So how do you actually benchmark it? That's the biggest problem. um, Dhruv, can you go to next? Second is that what even AMI to a large extent isn't call center noisy long form audio, what Abhigan was talking about, right? It isn't that. It is just studio quality recording kind of data. So how do we get that? um, and then of course ASR. And another thing, like little from the engineering perspective and from the research perspective, is that the audio encoder that is there, usually it is optimized for ASR, right? You have ASR heavy things, but too much optimization or too much training on ASR heavy kind of tasks lead to bad speaker discriminative features that come downstream. So that's another challenging issue. Like, how do you get good at speaker diarization without loss of ASR quality, right? So, and the last and the most interesting problem in diarization, and I would say an unsolved problem right now, is can we tightly combine these two, right? Can we jointly train? Can we jointly infer? But this is again an open field, and we are trying to progress and do some work here. But this is again work in progress, and actively we are working on doing R&D here. Yeah. Right. So I want to introduce our speaker diarization model. It's currently available in the batch mode, where you can, and it is specifically optimized for longer audios. And Dhruv will actually give you a walkthrough on how to use it. But Dhruv, do you want to go to next? So before that, as I mentioned, and as many people have asked, is where are your benchmarks? So we are releasing a first indic focus multi-speaker benchmark. This benchmark has been submitted at a major conference, and we will be once we are clear there, we will also be releasing it out for the public as an open source evaluation platform, right? So that people can try their own models and get their diarization and ASR scores. Okay, so it's completely in-house curated. It covers 22 Indic languages, and from 1 0 to 1 hour duration. And yeah, and we have special annotators, so it is not pseudo labeled. It is actual humans who have labeled this data set. um, and it has up to 8 speakers. And finally, the most critical part is a significant overlap, right? So that is another thing, getting overlap aware kind of ground truths in Indic context also has been a real big challenge. So yeah, our diarization kind of data set that we plan to release very soon will cover all of this, and you can reproduce the scores that we will show you. Dhruv, yeah. So currently the model, so on this indic dir bench, we have the kind of the best diarization error rate. And when we look at an indic focus, we are very close. With Pioneer, I would say like just a few decimal points away. And this is the Pioneer AI, the paid API, not the open source one. The open source one is quite down, and you see all other commercial providers. I think we are quite ahead, and the reason also is that a lot of these commercial providers do not focus on getting overlap. They kind of because it's very safe to not kind of show overlap, right? And it's easier. Like, but can you show overlap? Can you show two people speaking at the same time? Those become harder problems. I think that is somewhere where we want to be uncompromising and show multiple speakers, because be it Indian news debates or call center kind of audios, you have multiple people speaking at the same time. So you want to capture everything and give the flexibility to the user to actually choose whose voice they want to keep and whose voice they want to actually drop. So yeah, I'll be showing you one cool demo. Dhruv, maybe you can stop your sharing. Thank you. Something in beta right now, what we are working on, something really cool. But before that, I want to just show you the current experience. It's already good, but there are some really cool things we are working on. Just listen to the audio. And this, if you see, we show the overlap that happens around this particular time, right? It's around 11 to 12 seconds. So you can see at about 11.55 to about 12.53, there is a more significant overlap here. So let's listen to this audio. So you can see that, right? This ye bhi hai was spoken by the speaker, and this ye bhi hai.
Yeah, we are, I think, not able to see the stream. Could you try resharing once?
Oh, is it?
Yeah,
Oh,
we
I think
couldn't
now
hear
we
you.
can see.
Oh, not able to view the same. Okay, let me stop sharing and share again.
Yeah, I can
Fine.
show the demo from the start.
Is it showcasing now? You guys are able to see?
We can see.
Oh, sorry about that. Okay, so I'll just repeat that. So basically, I wanted to show you some cool beta features also that we're working on as a sneak peek, and also what currently we have. So currently we do get multi speaker transcripts. So here I just visualized the speaker time, and this was a multi-speaker, two-speaker audio, and I just want you guys to listen to it, okay? And I'll just start.
लॉन्ग रूट होगा ना ये. इफ यू कैन डायरेक्टली, अगर आपके पास बजट है, वो आप पैसे अगर आप इकोनॉमिक ग्रोथ में, पॉवर्टी को हटाने में लगाओ, गरीबी वगैरह पढ़ाई लिखाई में लगाओ, तो वो भी है नेशनल प्राइड. तो
So around 11 seconds, 11 and 12, you could see that there are multiple speakers actually speaking, right? And our model kind of captures it right. One issue or one thing that we is I think again the hardest problem in multi-speaker ASR is like when there is overlap, right? You get repetition of transcripts, right? वो भी तो है is fine, but this ये भी है. If you see this ये भी है, this is actually repeated in both the places, right? So the woman clearly says ये भी है. Just repeat it.
तो वो भी तो ये भी है.
So you could see a second speaker saying ye bhi hai, but because the diarization labels of course are a little bit shifted and a little bit more than exactly, and ASR cannot distinguish which speaker spoke what, it will transcribe that also in its own chunk, and you will have repetition over here. So in this, if you look at the new model that we are working on, it's a sneak peek again. Same audio, just listen to it again from here.
पॉवर्टी को हटाने में लगाओ, गरीबी वगैरह पढ़ाई लिखाई में लगाओ, तो वो भी तो ये भी है नेशनल प्राइड. तो वो भी है ना नेशनल.
So you heard ye bhi hai. This time the model was actually able to not only do speaker diarization but capture the overlap, but in fact during the overlap it was actually able to pull apart the speakers and assign the right word to the right speaker, right? So this is something that I think nobody in the market right now has this feature. And we are also actively working on trying to bring this to all of you, right? To try to get this out where you can actually in noisy call centers, or in news debates, you see people shouting each other over each other all the time, to try to be able to get this to you guys. So it's in beta, and we hope to release this very soon. So yeah, so that kind of concludes the demo. I think Dhruv, do you want me to take over the slide sharing? I can
Please go to slide 41.
okay. Screen, how do I? It's not full screen, right?
Click on present at top right.
Okay. Yeah. I'll just go here. Yeah. Okay. This is right?
Yeah.
Okay.
So, hey everyone, I'm Dhruv Rathi, but not the one in Germany. I work as a machine learning researcher in the ASR team. So we just heard Aditya sir and Abhikan sir cover the use cases of Saaras V3. I'm here for the API walkthrough to show you how to actually use this stuff. So let's just directly get into it. Aditya sir?
Yeah.
You can just go to the final slide. We don't need to do carbon. Yeah, so there are three ways to use this same model. You can pick by audio length and latency. Of course, there's this REST API, which is synchronous. The audio limit is 30 seconds, which is meant for short clips and voice bots, etc. There's the batch API, which is async. The limit of audio here is 1 hour. So you can upload, go make chai, and then come back for the results. Then we have the third, streaming, which is WebSocket based, and we promise sub-second TTFT. It's meant for live captioning type of use cases. Anywhere the user is, for example, talking and you want to see the transcript in real time. And so depending on the modes, so streaming has 3 modes. For fast and balanced mode, the audio limit is 500 millisecond and 1 second respectively. But we would of course prefer you send us audio chunks of let's say 100 millisecond. So we can keep giving you streaming outputs. So same Saaras V3 model behind all three. So final slide. Yeah. So by the way, all these code snippets are available in the Jupyter notebooks in the Sarvam AI GitHub repo and our documentation. So here I just wanted to cover that most STT APIs just give you text, but Saaras gives you the option to choose between 5 different type of output modes. So most of us have the habit of switching between languages when we speak naturally, right? Right. So Western models especially drop English words, like when you're code switching mid sentence. Saaras doesn't do that. So for example, if I say Mera phone number hai 9264987747, the 5 different output modes are, first is transcribe, which is basically number normalized, that audio ki script mein we get the transcript, but the numbers are in English script. Second, we have translate. The entire sentence is directly translated to English. Third, we have the verbatim, which is a direct phonetic one-to-one mapping of what the user has said. Fourth, we have the transliterated, which is romanized. This is like how you type in WhatsApp. So, and fifth, we have the code mix mode. So basically each language in its own script. So all this happens natively during decoding. This is not a post-processing step. And by the way, please don't call this number. This is just my colleague's number. Yeah, then we have language control. So of course, if you know the language, send it to us. You will have better accuracy. You will have better ASR outputs. But in case you don't, you can pass it as unknown, and we have LID on our end. The model will figure out, but this is only for actual cold starts when you don't know the language. Aditya sir? Yeah, and next we have batch API. So basically there are 6 steps. You create the job, you upload the files, and we'll start processing. We'll have a callback to ping you when it's done, and you can download the results. So as informed before, diarization is only available in the batch API, and then also the limit is 1 hour. And then we would, of course, here also, like same with language, we would prefer that you specify the number of speakers. But in case you don't know, we again will detect it automatically on our end. So as covered before that, we have also been working on Indic Direction benchmark, which covers all these languages. We have submitted to InterSpeech and we are hoping to release it quite soon. So at last, we have the streaming API, which is still in beta. So we have three types. First is the fast mode, which is sub 200 millisecond TTFT. Second is the balance mode, which is slightly slower, but the partials are much more accurate. And then we have the non-streaming. Basically, the full transcript you'll get at the end. So you'll have the best accuracy here. So you have one WebSocket, you have one parameter, you can switch the behavior without re-architect. So of course, I can't tell you about the model architecture, that's confidential. But what I can tell you, it's a encoder decoder based model, and generally the encoder is non-causal. So the encoder looks at both the previous context and the future context while making the representation. But what we were able to do, we made the encoder causal. So the encoder is now only looking at the past audio context when making the representation. So this also allowed us to cache these representations. So when the new audio comes in, we can still use the previous cache. So I'm pretty sure you're like tired of seeing slides. So I'll just do a live demo of the streaming API. Aditya sir, I'll share.
Super stopping. Yeah. Just before oh, before saying that, before you get it on top, just so that Dhruv is our engineer with many hats. He does everything from the research to the end model optimization to even the API layer. So yeah, Dhruv, take away the demo.
So yeah, so I'll just do a simple demo. So language I've given us Hindi and we are demoing the fast mode. मैं अच्छा खासा मॉडल बना रहा था, फिर इन लोग ने मुझे वेबिनार में बुला लिया. So as you saw, the model predicts as soon as the audio comes in. So it has the ability, but it has the ability to correct itself as more audio context arrives. So I'm done with my presentation. Sahaj?
Sure. I think, one thing is that, so like we mentioned at the start, there is something exciting, right? We want to hear some feedback on exactly this model. We want people to test it out. Again, it is still in beta, right? So we will need people to play around with it to sort of stress test it and to give us that feedback. I am putting the link where you guys can register for this beta program and work a little bit more closely with us to give this feedback. Please do register, please do log in. We will probably be rolling out the beta access sometime next week, but till then stay tuned. We will make sure that even the beta is as close to production as possible, but always eager to hear your feedback. I think your feedback is what shapes our model still date. It is how Saaras V3 has gotten this far, and it will be critical for us to make sure that this real-time streaming version also takes up, right? So yeah. Dhruv, could you also bring up the slides once more? Right. So one other thing that we also wanted to talk about, right? Of course, we went very heavy in terms of how the kind of use cases we have, the kind of modeling insights that we have followed, and then we talked a lot about the API features also. We also want to give you one sneak peek of something that is actually working in the real world and working really well, right? So Dhruv, you can bring up the full slide. So one thing is, couple of months back, right? I think about 6 months or so back, HealthPlex reached out to us, right? For those of you who don't know, HealthPlex is India's largest EMR provider. What is EMR? EMR stands for Electronic Medical Records. This is essentially folks transcribing OPD, IPD conversations for doctors between doctor and patient, transcribing that conversation as it happens on the fly, and then ultimately putting it in a structured report format. That is the solution that HealthPlex works on. And they have done a brilliant job at it. They reached out to us 6 months back with one problem that, hey, look, there are certain things that are not captured well in the Indian context, right? Particularly with respect to disease names, medicine names, because again, right, Indian languages, there's countless ways to say a medicine name. One of the examples they told us that was that a doctor, I think somewhere in the north, I think from Haryana, in a very heavily accented way said that, hey, मुझे अपने गॉल ब्लैडर की वजह से कुछ प्रॉब्लम हुई and that gall bladder got transcribed to girlfriend, right? So there are those kinds of things that happen, right, in the regular transcription, and that is the problem that we wanted to solve, right? Regardless of, let's say, dialect, regardless of, let's say, the language that is being spoken, regardless of the setting within which the audio is being captured. Because if you think about it, doctor patient conversations are going to happen in clinics around the country. It's going to be noisy, it's going to be, recorded through laptops, which not necessarily a very strong quality microphone also, right? It's going to be some distance away as the doctor checks up on the patient, right? So it's going to be distance, it's going to be low quality, it's going to be noisy, and it's going to be raw, right? That is the audio that we want to be able to transcribe. That is the kind of audio that once we can transcribe will actually make a difference. We have been working on that problem, and we have, I think, achieved a very fair degree of success within it. As of today, within HealthPlex's Halo solution, our ESR is working at scale. 14,000 plus doctors are using it today across the country. And the key thing, right, for every doctor using this solution, why this problem really stood out to us also, right? Every doctor that uses this solution has to spend that much lesser amount of time writing, let's say, a report, right, for the patient to take up, right? He doesn't need to write, he doesn't need to note down things, he doesn't need to pass on things. Why? Because the audio is captured, the transcript is ready, it just flows into a structured report and it's ready for anyone to download and access immediately later on, whatever, right? The record is stored. So that is something that the Halo solution is able to do really well. And again, this is just few minutes saved per conversation, right? Probably 2 minutes per conversation. But when you add this up across all the conversations that doctors have during the day, you end up saving about 1.5 hours per doctor per day, which eventually could translate to about 5 more patients catered to. So this kind of a problem has that real world impact, right? It's something that gives us that pride to be working on this thing. And we would absolutely love if more and more of you folks can build such solutions across different industries. Again, the beta program, which you guys can access to give us feedback, will be a very big step towards us shaping this. And we really eagerly look forward to, the feedback and the kind of things that you will build in the future. So yeah, I think that sort of covers it. Is there a slide? Huh. I think, one thing also to talk about is in terms of our journey, right? Again, I cannot stress enough how important the community is, right? The very fact that I think yesterday or today we have crossed 10,000 members on our Discord community, right? We started from zero. I remember a time when, we were just trying to understand what different use cases do. And today on Twitter, we see people, putting out use cases left, right, and center with our APIs. The scale, the love that you guys have shown our models is immense. The kind of feedback that you guys have given has also been brutal, but it's very much appreciated and required. So please do keep that coming. I think, the applications across different industries, let's say things like HealthPlex has built for Halo, or let's say other language learning apps are building, is going to have real impact across different industries, right? Be it BFSI, be it quick commerce, edtech, whatever you can think of. Any place that touches voice, please do build in. We also have a startup program for anyone who is actually building deeper, right? Who is actually wanting to scale but doesn't have the right means to, let's say, hit a higher throughput or enable, let's say, higher number of credits. Please do apply to the startup program. I'm sure someone will also post the link in the chat. Again, if you have not received a response, we will make sure that that gets cleared up. So that is something we will take care of. But yes, please do apply. We will do our best to support the community throughout. And most definitely, we look forward to your feedback. So yeah, that's it for the portion so far. We will now start off with a Q&A. We'll probably, pick up a few questions that you have put up across the chat. I think there's few from LinkedIn, Twitter, so on. So we'll just pick out a few questions. Dhruv, Aditya, again, I'll probably call on you for a couple of them. And yeah, let's just dive straight into it. So one thing, right? I think let's clear this up. I see quite a few questions regarding the pricing also. I think that's the very first thing to cover. So our pricing is available on our developer docs as well as the dashboard. I think Vinayak will be sharing both the links for the dev docs and the dashboard within the chat. Essentially, at the public price, we are at 30 rupees per hour of audio transcribed. Again, that is billed at the per second level. So there is no rounding up, no rounding down, nothing. It's billed at the per second level. And only for actual audio that is sent, right? If let's say there's silence within your audio, that's not something that we will bill for, right? So that's something that's there. Again, for higher volume, use cases, please do reach out to us. If you're building something for a startup, there is the startup program. We will make sure that folks that have applied will hear back from us in a shorter duration. And yeah, I think that is that for the first question. Where to enroll for the streaming model? We have pasted the link in the chat. Please do enroll for that. There's also a question which is on how many separate speakers can be diarized at a given point of time. I think this is one interesting question. Maybe I'll ask Aditya to jump in here very quickly. Give us some insights in terms of how complicated it is as we add more speakers. What are the different things you will be able to deal with, as well as probably where we stand today.
Yeah, so I think we can, as Vinayak rightly pointed out, we can handle up to 12 speakers. But from practical use cases, it is most accurate up to 8. When it goes larger and larger, there is some loss, at least in very complex scenarios. Um, so yeah, I would recommend to try up to 8. But yeah, which so that's the recommended thing for people to play around with first.
Amazing. There is also one other question along similar lines, Aditya. So there's a question saying that, suppose if speaker one is speaking, let's say, hey, how are you? And someone is also speaking in the background. How would this kind of a situation get handled within the transcription model?
Right. So I think a couple of things, right? I think the use case, what I see people asking is that, hey, I have a voice bot. I'm streaming the ASR, and I just care about that person's voice being captured and not in the background. So that is something that is a different problem, where you want to be more robust to the main speaker, or not even robust. You want to say that, hey, I'll just talk about the main speaker and be very and not transcribe the background speaker. That is that problem. Of course, if you give it to a diarization model, it will tell you two speakers, but diarization per se right now is a batch kind of async process. And also we have tried to play around with the sensitivity. Problem is it's like a lever, right? If you try to actively only transcribe a foreground speech, sometimes when a person is genuinely speaking in low voice, the model is like, that is just background noise. So it's a complicated game to play with. What we can tell you is that we are looking at more innovative solutions to this, where we are thinking that there should be a switch to play around, and for your use case you should be able to set a switch that says, hey, how much of the background speaker you want to transcribe. But that again, something which we are working on actively. If Abhigan wants to add to that, I think.
Yeah, I think there are a couple of questions on background noise and the latency. I'll maybe take both of them. First, on the background noise part. Uh, so, Diana, you have posted that during live call, Saaras V3 handles regular environmental noise well, but when nearby people speak or parallel conversations happens, those voices are sometimes captured and transcribed as the active caller speech, which affects downstream LLM responses. This is exactly how you sum up the challenging problem that we are trying to work on and trying to solve. Uh, so there are two aspects to it. What kind of background noise it is robust to? Anything which is related to telephony noise, anything where there is, let's say, non-human sounds are there, uh, uh, traffic sounds or weather sounds or something like that, it's quite robust too. But when you pointed out clearly that when there is background speech or someone else is talking over, then it sometimes breaks down. That is something that we have been, and Aditya showed a sneak peek on what we are building. That's an important problem that we are trying to. It's a challenging problem in general. You are asking also next is, are there recommended configurations? Here I'll tell you that the new streaming API that we are releasing will have some recommended suggestions, and much more control on your side. So it's a saying, right? The same shoe doesn't fit all. So in different scenarios, the VAT settings, the diarization settings, and the other configurations would be needed to be differently tweaked. So we will, with this new streaming API release, we will give more control to you and have do or use case specific recommended configurations. Right. Yeah. So that is on the background noise part. Yeah. In short, the newer models are much better. We are actively looking at background speech or overlapping speech as a problem, and we'll hand over much more control to you in terms of VAT settings and other noise related settings. Another question I'll take, which is on the latency part, which is you're saying that the latency has been a complaint. I saw a few comments where it's saying that is it hosted in India or US. So I'll tell you, see, latency is a load dependent problem, and that is something that we are trying to actively look into. Uh, at certain times, when the load is more, there is spike in latency. We are aware of that. Uh, Again, I'll tell you, do subscribe to our new program on streaming ASR. We are releasing WebSocket endpoints where we have changed bunch of things in the system architecture, how we have deployed, and we are seeing much more stable latency numbers, much more stable P95 latency, as some of the numbers you saw floating in the slides as well. Uh, yeah, so we have looked at problem ground up, and we have re-engineered the system. We would still want to hear your feedback, where it is, what is, I mean, some are genuine load issues, which sometimes the load is beyond the compute capacity to control. But there are genuine issues which we have tried to address. So do subscribe to that, and we can work closely on seeing where it is still lacking. Yeah, and similarly on the TTS side, I know a lot of people are putting TTS messages. We'll have a separate session on TTS. But as I'm saying that there are systems level changes that has, I think, Saj can elaborate more on that, but that has already been put out, which has fixed latency problem in TTS side to a very large extent. Okay, over to you, Saj.
Yes, absolutely. I think just to touch upon that point, right? I think definitely, right? If you look at latency, it's a, I would say, tricky problem, right? And especially on just touching upon the TTS side, since it was briefly mentioned, I think we are in the process of making a bunch of improvements. Some are already there, some more will come. So definitely stay tuned for that bit. Uh, I think one other interesting question, maybe for you only, Abhigyan, or maybe Dhruv also can chip in. For long form religious or classical content, let's say Sanskrit shlokas, Quranic recitations, how does the model handle domain specific phonetics that probably will not be within our training data set?
Okay, I'll attempt on it, and then maybe Dhruv, you can say more on it. Yeah, so you are trying to ask that how good it is on out of distribution, new kind of scenarios. So one thing is the model is quite robust in terms of handling different kind of domains, different kind of accents and all. Uh, Specifically on long form, this is another point that we have been focusing on. If you looked at the slides, the Sarvam audio is focused, the next iteration of Saaras will be really focused on longer chunks. Current, it does decently well, I would say. If you try out the new streaming API that we are releasing with much more tweakable parameters for long form, or the current batch mode API also, in long form it does decently well. Um, for out of domain context or domain words, there is an option of context. That is another thing that in the next iteration of the model you will see much more improvement. But still, if you provide some relevant context, it does kind of bias towards it. So if you have, for example, you are saying religious recitation or medical domain or any such domain, you saw a case study on medical, so it will, if you provide the context, and again, reach out to us if you're struggling in some of these domains and you want some help. It does out of the box should work decently well. In the next iterations, context is the key. Longer audio is our focus, so it should drastically improve. Yeah. If you want to add something.
No, I would say कि our performance on we have already covered so many domains. So especially on long form, I think our performance is already quite good. If there's any domain again which I disagree, we didn't miss any important domain. But if there is any domain where you think our performance is weak, we would of course love your feedback, and we'll of course try to improve on it, as said by Abhigan sir in the next version, which is server module.
Absolutely. One other interesting question. I think this question is probably comes up across every use case. What are the biggest challenges faced to reduce hallucination?
Yeah. So again, we clearly called out it's a audio conditioned language model. That is how field is moving. There will be cases of hallucinations. That is something that we don't deny. In every iteration of model that we release, we track these numbers, hallucination numbers, on our internal benchmark sets. And I can tell you with confidence that with every new release, these things are more tackled in different scenarios. But still, there will be cases. In fact, I was saying to Aditya the other day that one day I was working on ChatGPT and I saw hallucinations happening there as well. So how do you tackle it? So one thing which we are also enabling in the upcoming API release is handling at the client level itself. The hallucinations are something which are kind of model. It's unavoidable at model levels. It will happen once in 100 times or once in 1,000 times, once in a million times, but it will happen. At the layer on top of it, you can detect it, and instead of returning a hallucinated response, you can return a empty response, or you can call that out that you cannot output at that moment. That we are implementing, and it will soon be out. But the same thing you can do at your level also. You also get the output. You can use simple metrics like ZZip is a metric or speaking rate is a metric to detect hallucination, and to your clients, instead of sending the raw output, you can send this output. So yeah, so that problem is, I mean, widely known. We have been improving on that. At a systems level also, we are implementing changes, but there are easy fixes that I just told you, which you can do at your client level as well.
Great. I think there's also one other question that I think came up multiple times, and I think we have also discussed this internally. I think we have a few things in the roadmap, so I would love if Abhigan or Aditya can also talk about this. So the question is, for Saras, we have observed inaccuracies, especially during using things like code switching. Right, like when there's a mix of Hindi and English, when we use the code mixed mode, there are some inaccuracies or inconsistencies that pop up today. So how are we planning on improving that?
Yeah, I'll take an attempt at it, and maybe Aditya, you take second attempt at it. So yeah, we provide different modes, right? And I think there was a question on if you mix multiple languages, what happens? The modes, if you go by it, the default mode works best out of the box. Transcribe mode, as we call it, where what you say is in your native script, or the native script of the language that you specify. And the digits are normalized, which the numbers are normalized, which means that it will be in digit form. But there are other modes like code mix mode also. So if you know that it's a code mix heavy sentence, then what we would suggest is use code mix mode instead of using a default transcribe mode. The reason is you will see that slight in accuracy also. What about Indic languages code mix transcription? Yeah, so that's what. So code mix is a mode that you should definitely try if you have a lot of code mix. And by the way, for people who may not know, code mixing is native script mixed with English. But if you have cross-lingual audio where it is, let's say, Kannada and Telugu, there the script will still remain one of the two, either Kannada or Telugu. Uh, the output, there could be inefficiency. That is something that right now we don't guarantee, that if you have multiple languages in a single audio, out of the box it should work okay, but we don't guarantee that there will be kind of, it will be flawless. But for native mixed with English, which is code mixed, There is a special mode. Please try it out and let us know the feedback. Aitya, if you want to add on this.
No, I think that covered it. Maybe in the future we'll have Indic code mix probably, but right now we work backwards also from where we see a lot of use. People want English kind of words, loan words that they call it, to come in English. So yeah, but maybe in the future, yeah.
Cool, perfect. I think we are right on time. So it's 6 p.m. We don't want to take up more of your time. Again, I hope that we were able to give you some insights into how the model works and hopefully give you some more inspiration or direction to build more. We are very excited to see the kind of things that you will build across industries. I know there are a lot of more questions that are coming in. Again, please do join the Discord. We'll try to answer as many of them as we can over there. We'll try to support you in whatever way possible. And again, please do register for the beta program also for the streaming API. Any and all feedback will be much appreciated. And yeah, I think that's it. So and of course, right, for folks who are also building and are looking to scale quickly, do apply to the startup program. We are rolling out the responses in batches. So if you've not heard back yet, you should hear back fairly soon. Just stay tuned. Please do apply. We are looking at each and every application in great detail. So yeah, looking forward to all the things you build and please do keep giving us the feedback. So yeah, thank you so much.
Thanks, folks. Thank you so much, everybody, for joining.
Thank you for joining.